Yo, testing 1 2 3, testing 1 2 3. I believe we're ready to get started here if I'm not mistaken. I think we got everything all set up here. Yo, what's up? Welcome back to Vencabot. Intro to Python action. My name is David. Yo, it's day 3 here. Intro to Python. That is to say, we've actually been working on this project for 2 streams. And the idea is that with every stream we do, we sort of bring in a couple more advanced ideas into our programming toolkit. The very first day we were talking about what is a program, right? How do you write a program? What does program flow like? You know, what kinds of data do we have access to? All these very, very basic ideas that are the first part of how to begin programming as a total novice. And then the second day, we added some new data types to our library. We added some lists to our tool set. We added some dictionaries as well. So before we get started here, let's do the ceremonial thing and go through our code, which is very short right now. It's just that long, and can you believe it's the whole game? This is a whole game right here. All this is a little bit of text. And we're going to go through and see what all this does. Before I do that, I'm going to read these messages here. So Kenny says, I had to dig out an Ethernet cable from my box of endless cables. Yeah, I'm kind of the same way. I've got a lot of spare cables, but many of them are kind of short, right? They're the ones you get with routers and modems and stuff, which are pretty short sometimes. So on our very first day of programming, we learned about things like simple assignment, right? Like this statement right here. Right, where we say on the left side, we give a variable name that we can choose, which is what we want to refer to our data as throughout our program. I'm calling this one game state. And then you have the equal sign, which is the assignment operator. That'll say assign some data to that name. And then you have the data you want to assign. In this case, we have an empty dictionary. Now, on our first day, we didn't know what a dictionary was. Right, we had no idea what the hell a dictionary was. We knew about integers, which are basically numbers. You know, like these right here. This is an integer, 25. Here's one, 6. And we knew about strings on our first day. Strings are a textual data, such as, what's your name, son? And a potion. And what monster do you face, right? You can always tell a string because it has quotation marks on either side, right here. And in this idle editor, actually highlights strings, as you can see. The strings are a different color. Now, on the very first day, I pointed out to everyone that you can actually program using only Notepad. And it's very simple. You don't need any special software to write Python code, or any code, mostly. All you need is Notepad. And it's a pretty convenient, pretty nice. Everybody's got Notepad, right, if you're on Windows. But on our second day, we introduced the idea of idle. That's IDLE. And idle is a Python editor that comes with Python. So if you want to use idle for your scripts, all you got to do is, go to your folder where your, I don't want this, I want the intro to Python folder. Go to where your .py file is, which is like your text file that has all your Python code in it. Then you right-click it and select Edit with Idle, then choose your version. Most people only have one version that came with their version of Python, right? When you edit with Idle, what happens is you get this beautiful little notepad, essentially. It's kind of like Notepad that comes with Windows, except that the colors are different, as you can see, and they have highlighting on your text that kind of helps you understand what's going on in your code. As you can see, certain keywords such as while and if and Booleans, false, def. All these things are one color. You also have strings, which highlight differently. You've got function names, which highlight differently. And that kind of makes it easy to scroll through very quickly and get a feel for what's going on, right? That's kind of cool, I think. But yeah, so on our first day, we knew about integers, which are numbers, and we knew about strings, which are textual data, usually to show the player at some point, right, or the user, or whatever kind of software you're writing, right? Maybe it's not a player, maybe it's just a user. In any case, computers really have no use for strings, right? Because they're not going to be doing math on strings. They're not going to be calculating data based on strings, typically. Sometimes you will. But most of the time, if you have a string, it's really there for an end user to see, like a human being, such as, again, we're asking the user for their name. We need a string for that. We have some data to print off. You know, when someone tries to use a thumb drive item, it prints off this data, right? Basically, things you're going to tell the user are oftentimes in string format. And strings, again, are just text. So we really only knew about those 2 kinds of data on the first day. And then on our second day, we learned about another simple data type called a Boolean, or a bool. Booleans are very, very simple. All they are is true or false. Right here we have a Boolean, false. Right, if we go down here, we'll find, if we go to like turn defend, right, here we go. So we have a true Boolean. There's only 2 Booleans, true and false. That's kind of convenient. And what's cool about Booleans is that they're used for logic, right? Such as, if I were to go down here, and we want to find out, if the monster is still alive or not. If the monster's still alive, he gets a turn, right? If he's not alive, he gets no turn. Here we say, if the game states monster HP, so if the monster's HP is greater than 0, then run this code. Now, what wasn't clear in our first day programming is that this statement here is basically a math statement. is saying, is this value greater than 0? Now in math, you have things like, 1 plus 1 equals 2. You've got, 2 divided by 1 equals 2, right? You have these kind of mathematical operators, but this is a Boolean operator essentially. This is called a comparison operator. And what it does is it compares two things, and instead of 1 plus 1 equaling 2, this greater than this equals a Boolean. It'll turn out to be either true or false, right? So this is kind of like a little comparison operation here. And comparison operations typically return a Boolean, true or false. So here we say, if this comes out as being true, then we run this code here. If not, we don't run that code. So Booleans are very useful. Oftentimes you don't even see them, right? Like right here, you don't see the Boolean. It's just that we're returning a Boolean value. You could replace this code with, if true, then that would always run, right? Because if this second part is true, then the if block will run. So if true will always run, and likewise, if false would never run. But we're not actually going to include a Boolean literal. We're not going to put in that hard-coded Boolean value. Instead, we're going to find a Boolean value by running this code. Right? So that's kind of how Booleans are used most of the time. I shouldn't say most of the time, but a lot of the time they're used in a way that you don't see the Boolean literally in your code. It's just that you evaluate to a Boolean. Also, we have another Boolean operator up here, the AND operator. Now, AND is an operator, again, kind of like a mathematical operator, but it only works on Booleans. So AND will only return true if the statements on either side of it are both true, right? So true and true will equal true. True and false will equal false. False and true will equal false. And false and false will equal false. So the only time you get a true out of an AND operator is if the Boolean statements on either side of it are both true, right? So only true and true equals true. And that's why we're using it right here. We're saying here, if the monster is still alive and the player is still alive, then run this code, right? So they both have to be alive to run this code, and it's thanks to this AND value, right? Now, we could say or is another Boolean operator. We haven't actually looked at that yet. It's not quite as useful in day-to-day programming, but it is something you have to be aware of. Or is another Boolean operator, but it'll return true if the value on either side is true. Right? So true and true equals true. And false and true equals false. Because they both have to be true, right? However, true or true will equal true. Because one of them is true, at least. Actually, both true in that case. But also, false or true will equal true. Because again, one of them is true. And only false or false will return false. So I'll say, run this code if one of these at least is true. That's what or means. It means, if one of these is true, then run the code. If they're both true, that's fine as well. And finally, it's not really as important at all. You're going to use this maybe, once in a while in your code, depending on what you're coding. But just to be complete here, so we're talking about and or, I have to mention XOR. Wait, does XOR not exist in Python? It's not getting highlighted. Well, in most programming languages, you have a XOR. It's exclusive OR. And that means that only one of these can be true. Right? So we mentioned before that OR, as long as one or the other is true, then it's fine. True or true is true, and false or true is true. But XOR, again, I'm not sure how you do XOR in Python. I'm going to do a quick Google search here. Okay, so I guess Python doesn't have a XOR. You have to do it. You have to do it like this, which is a little bit more involved. But just for your information, guys, in most programming languages, you have a XOR, and XOR means that only one of them can be true. So true XOR false will be true, and false XOR false will be false. But true XOR true will also be false, because only one can be true with a XOR. Anyway, so we know about 3 kinds of Boolean comparisons, and, or, and XOR. We know about, mathematical comparisons that return a Boolean, such as greater than or equal to, or less than or equal to. Those all return a Boolean as well. We get Booleans out of this in statement up here that we learned in our last stream, right here. In is a sort of comparison or a logical operator that will return a Boolean based on whether some value is in a list. So here we're saying, if the roll of toilet paper is in the player's inventory, run this code. So it's another little operator there, in, that will return a Boolean value to use for logic, right? To use for if statements and while statements and that sort of thing. So again, Booleans are really mostly there for logic, true or false values. They're good for if statements and else statements and while statements and all that good stuff. They're pretty neato. They're very useful. And so those are kind of like our three simplest data types that I have access to right now, right? We have integers, we've got strings, which are text, and we've got Booleans, which are true and false. And then last time I learned about some more complex data types, which are very, very useful, such as the list. This is a list right here. Right? A list has a square bracket on either side, and you can include a list of comma-separated values. So here we've got a 1, 2, 3, 4 strings we're including in this list, right? So before we have like a name like game state, and it would be assigned to one value. But when you have a list, you can assign to one value, but that one value is itself a list of a bunch of values, right? So the list itself is one value, but the list contains many values. So here we've got a 1, 2, 3, 4 strings in this list. And there are two really cool things about lists. One is that you can check to see what's in them. Again, with that in operator, that gives us a Boolean value. You know, is this in that list? If so, then do whatever. That's kind of cool. But also you can do a for loop on a list. And a for loop is a loop that will execute some code repeatedly over and over again. And it will do that code once for every item in the list. So if I go up here to the player inventory, when you want to use an item, right? Here you want to use an item. You know, you choose on your turn. It's an RPG, guys, like a JRPG. And you can either attack, defend, or use an item, right, on this monster. And you have an inventory. If you choose that you want to use an item, we say here, for an inventory item in the player's inventory, execute this code. Print off 4 blank spaces, and then the inventory item. So what we're saying here with this for loop is, for everything in this list, print off its name, basically. So we're going through every item and printing off its name individually. That's what we're doing there. It's kind of cool. That's one really powerful use of lists, is that you can iterate through them. It's called iteration, or going through every item in that list and doing a thing using the for loop. Karen says, doing some digging, suppose you can do up caret or does not equal for XOR if both sides are bools. Well, no, does not equal wouldn't work, right? Because false XOR false returns false. If you use does not equals, then you would get false, you know, does not equal false. That would be. No, I guess you're right, Kenny. That would be correct. All right, I guess that makes sense. Yeah, so does not equal statement. What Kenny's showing us here in the chat is you have this statement for does not equals, right? I'm gonna go down here and just demonstrate it real quick. Yeah, it does, Kenny. I'm pretty sure. If not, you can just use the word not, but. Yeah, so you could say, like, you know, if, true does not equal true, then you could say, you know, print, the two statements are not the same, right? So in most programming languages, including Python, I'm almost certain, I'm pretty sure. In fact, we can just run it right now, for instance. Let's just run this code and just make sure we don't get a syntax error. Yeah, no syntax error. So yeah, so that does work, right? If I were to put in here true does not equal false, then that would actually print off that message, right? No, I guess I'm wrong. Didn't print it off. So I guess you'd have to use, what is it doing then? Sorry guys, I'm gonna get sidetracked here. You sidetracked me, Kenny. Let's save this, as I use so many languages, guys. I'm kind of surprised this is not a, this doesn't work in Python. Let me see here. That occurs later, doesn't? Oh, does it? Oh, okay. Thank you, Kenny. Okay. I'm sorry. I was confused. Yeah, you're right. So if we punch in David, it'll say here, David's also the monster. There you go. Okay, thank you, Kenny. Thank God. I thought I was going to go on a huge tangent there, trying to figure out why the hell that wasn't working. Kenny's got my back. Okay, so yeah, so basically, when you use this notation here, anytime you use an exclamation mark in Python or any programming language most of the time, it means not, right? So not equal to. You could also say in Python, you could say the word not. You would say not equals equals, but that works in Python as well. And in most languages, that's not the case. In most languages, there is no not keyword. One of Python's core values as a language is to be human readable, right? To make it as easy to read as possible for human beings. So they added this not keyword, which means the same thing as an exclamation mark. But yeah, so Kenny's right. This would work as a XOR as well. Because if you had true, XOR true, that would be false. And if you had false and false, that would also be false. You would need to have two different values. You could use you had to use true does not equal false or vice versa. Thank you, Kenny. That's some pretty good insight there. Anyway, sorry guys, I got a little bit sidetracked. So we learned about lists last time. They're very useful. And we learned about dictionaries, which is the most complex concept we've had so far. It's a relatively complex concept compared to what we've been looking at up to this point, and that is in a dictionary, or it's also called a map, you can kind of relate two pieces of data together. I'm going to demonstrate that up here. Where's the best place to demonstrate that? We'll look at this dictionary up here. Right, with this item map. Dictionary always has two curly brackets on either side. Or I should say one curly bracket on either side. Like this. And what you do is you will take a list of keys and values. The key is a piece of data that you can use to get the other value out of the dictionary. So for instance, if I were to use the dictionary's name and say, hey, I want the data that's at the key spear, then I'd get back this value here, which is a function. And same with the potion, right? So in dictionary, you've got a list. You can see the commas here, right? Comma-separated list. And each item in that list has a key on the left, and then a colon, and then a value on the right that you can access from that map, from that dictionary, using that key. So down here, we are making a dictionary, the game state, and we're using this notation here to add keys and values to that dictionary. So here we have the protagonist's name as one of the keys in that dictionary, and we're adding in whatever the user wants to punch in, right, the input. Then we're adding in their HP, and we're making that dictionary value equal 25. So that way, later on, when we want to access the player's HP, we can do it by doing this. Right, if I were to go down here, you can say here that we're going to change the protagonist's HP by saying, protagonist HP equals then some value. Right? It's kind of cool. Hey, what's up, Zanzi? Welcome aboard, man. Alright, so before I actually start doing new stuff for the day, I want to one more time go back to the idea of code blocks, which, if you look at our code here, you can see that it's not all indented to the same level, to the very least, right? Some of this code is indented really wacky. So we start off, a lot of this code, like right here, is on the far left of the screen, right? Game state, we define the game state, we define the protagonist's name and his HP and his attack power and whether or not he's defending. It all happens here on the very left side of the screen. What this means is that anything on the far left of the screen runs, let me rephrase that. Everything to the same indent level runs top to bottom. Right? So all these things are in the same indent level, they're running from top to bottom. All these functions, the first line of each one is run top to bottom. Right? But as you can see here, the second line of each function is indented by 4 spaces. I'll go up here, you'll see the same thing. Right? The second line is always indented by 4 spaces after you do a function definition. See the DEF? That's a function definition. Right now we're reviewing Zounds. We're kind of reviewing what we did in previous streams, our previous 2 streams. Right? You see the function definition is all the way to the left. Then you see the next line is indented. That's true of all these definitions. Right here, same deal. Right here, same deal, same deal. Right? So what that means is that when we start our program, the first lines, these definition lines, are executed. So we define the functions, but they don't run. The function does not run, because the indented code will only run conditionally, and that's called a code block. So in Python, indented code is always only run under a certain condition. Right? So when you have a function definition, the indented code is only run when that function is called later in your program. So here we're defining the name of a function, and we can call it by name later to run this code. That's why it's indented. It's a code block. Code blocks always start with, a line that's at your current indent level, followed by a colon. at the very end of that line. And almost pretty much any line that ends in a colon will start a code block. So here we have, a function definition code block where we're defining a function and executing it. Here we have another function code block, right? And so on and so forth, all the way down. So none of these functions are run when we start, even though they're actually at the top of our program. As you can see here, I'm at the top of my program. These functions are not run. They're only defined up here. We actually run them later, right? And in some of these functions, you can see we've got, I'm gonna actually ignore this for now and come back to this. See this indentation here? That's a separate kind of case. But as you see in some of these functions, such as right here, we have this for block, right? So when you run this function, all the code that's indented far left is going to run. So we define our item map. We print off this statement. They're both indented the same. And then we also start this for loop. So the reason why it's not indented is that this for loop is evaluated. It's saying, for every item in this game state. And then this block of code here will only run if the list has some value in it. And then it'll run again and again and again until we've gone through every item in that list. So basically, anytime you see a code block or some indented code, that code is run outside of the normal execution of your program. It might run more than once. It might not run at all. Right? For instance, we have this if block right here. This if block might not run at all. It says, hey, you want to try and use the spear? This is the spear using code where you throw the spear at your dragon, or throw your spear at the opponent. It says here, if you have the spear, right? If the spear is in your inventory, only then run this code, right? We have this code block here. And if this ends up not being true, if you don't have the spear in your inventory, then this code does not run. This code runs conditionally. And we have an else block down here. Else is a kind of block that says, if the previous if block did not run, then run this code instead, right? So this code does not run, and this code conditionally, because it's indented, right? It only runs conditionally, will run. If this code does not run, then this else code will run, right? It says you don't have the spear, right? If you have the spear, then throw it. If you, otherwise, says else there, then print off you don't have a badass spear. So that just says, we're getting pretty advanced for my tired brain. I even took a 3-hour nap at noon. Naps are the best, dude. Especially a long nap. That's what's good. What's up, 2 Average? We should randomize the attacks to hit or miss to make it exciting. Looking forward to 2 Average. You might have looked at my title here. Today we're going to be randomizing stuff and adding all kinds of cool features. So I decided last night when thinking about, what should our curriculum be for tomorrow? Right, that would be today now. I decided that our curriculum today would be making our game more exciting and more interesting as far as we could without adding in classes yet. So once we get to classes next week, we're going to be making our code much cleaner, much easier to expand, much easier to add new features and new monsters and new items. It's going to be a lot easier to read. It's going to be great. But the thing about classes is that it requires, like everything in programming, right? It requires a little bit of abstraction, a little bit of abstract thinking. And what's kind of crazy about programming in general is that as you learn more advanced concepts, your code actually gets cleaner and easier to read. Right? Whereas if you try and use a bunch of beginner concepts, it might be easier to understand for a beginner, but then your code will get longer and uglier and harder to scroll through quickly. Because these beginner tools we have are limited, right, in their ability to condense code into something manageable. Right? So we're going to try and stick with not using classes yet. And that means our code might get a little bit long in the tooth today, a little bit sloppy looking. But it's going to be some pretty easy ideas to understand. Every individual line will be very basic. But we're going to have too many lines by the end of tonight, which we're going to fix next time using classes. Anyway, so today we're going to hopefully add some randomness to our game, such as maybe hits will hit or miss. Maybe the enemy will choose a random action on its turn. Right now, the enemy always just attacks us with fire breath every single turn. Maybe it'll randomize its choices a little bit, and that sort of thing. Might even try and get more than one monster and randomize which monster we fight. That could be cool. We've got another hour and a half or so. So, we learned about, data types. We learned about code blocks. We learned about how to define functions. All these things. We learned about arguments in functions, such as this data here. So functions, there are bits of code that you can run at will when you call that function. But what's really cool about them, though, is that you can give them some data to use when you call them. So saying, hey, do this thing for me, but you're probably going to have to know this, and this to get that thing done. Right? So here's some arguments. These are things you can have to get your job done. And you supply these things between the parentheses when you define the function and when you call the function. And then you can use that data in your function, and then if you want to, you can even return some value at the end. So you can say here, I did my job in the function, I want to give you back my report on what got accomplished, here's the return value, right? So you gave me an argument, and I spat out a return value. That's typically how functions work, but we also learned last time that there are some data types that are called mutable data types. There are some data types like integers which can never be changed. They can never be mutated. They are immutable. They cannot be mutated, which means that if you supply them as an argument and you want some data out of your function, you have to return a new value. But there are some data types that are actually mutable. They can be mutated, they can be changed. For like our game state here. The game state is a dictionary. It can have things added to it, things removed from it, its values can be changed. And for that reason, you can run a function and supply it a dictionary as an argument. And then that function can just change the values in that dictionary and not actually have to return any new value. Because you don't need the data out of the function itself is changing some existing data. I know, if you guys watched the episodes 1 and 2 of this stream of this season, this is season 3 for Intro to Python. Again, we started off much more basic on day 1, and day 2 we talked more about how dictionaries work. I'm not going to go into that again today because that's going to be all available to you on YouTube. Anyway, so let's get things rolling here, right, for some new stuff. For one thing, I promised to explain to you guys last time how this line of code works. If we go up here to our item use, the turn item, right? So we have our functions, they're named kind of conveniently, right? The functions are named in such a way that you know what they do. If it starts with the word turn, that means that it runs that turn action, right? So turn attack is run when the user wants to attack the enemy, right? This is all the attack code. Turn defend is run when the user wants to defend on their turn. And turn item is run when the user wants to use an item, okay? And likewise, the functions that start with the word item, like item spear, item roll of toilet paper, item potion, and item thumb drive down here, those will run when the user wants to use an item on their turn, and they choose that item. Right? So the item spear contains the code for using the spear, essentially. Delicious. So, when you want to use an item, we have this item map. And what it does is it types in, the item map pairs the possible things the player could type with the function that will run when they type in that item name. So for instance, if they type in the word spear when they want to use an item, they'll get the item spear code, right? The item spear function will come out. If they want to punch in the word potion, then the potion function will run. Right? So the first thing it does here, it goes through a for loop, prints off all the stuff you have currently. Then it says here, what do you want to use? And we save that value as the player's choice. Now we're going to try. This is what we kind of didn't really touch on last time too much. We're going to try and get a function out of this item map. So it says here, the item map, the value that's at this key, right? This is that notation there. Item map's the dictionary, right? We define the dictionary right here. I want the value out of this item map that is at this key, the player's choice. If the player types in the word potion, then we get the item potion out, right here. If I typed in spear, well, then we get this value, the item spear function. And we're going to save that value as item function. But what's crazy is that if the user types in banana, okay, well, what's the value at banana here? We've got spear, we've got roll of toilet paper, we've got potion, we've got thumb drive. Oh, fuck. Oh my god, guys. We don't have a key at banana. So the program crashes. We get a key error. Right? And that will crash our program. If you try and get a value out of a dictionary that dictionary does not actually have, it will crash your program with a key error because there is no key of that name in that dictionary. What's crazy about Python, and pretty much every language can do that, every modern language can do this, you can use this thing called a try block. Right? Try. So here we're saying, just try to do this. Right? It might not work, it might crash our program, but just try it. Just try it, no big deal. Do your best. And if we get a key error, well, it says here, except key error. So this block here will prevent our program from crashing in the case of a key error. We will try this, and if we get a key error, just, rewind a little bit, and then run this code instead. So here we're saying if I typed in banana, right, we get a key error. That's fine because we're accepting the key error and printing off, the hero's name isn't carrying that. Right. So he wants to use a banana, but we can't use bananas yet. That's not in our game yet. That would crash the game, but we are actually just trying to do it. We're not actually forcing to do it. We're just trying it. And because we failed, it would crash our program. We're saying, on second thought, I don't want to crash it. I don't want to crash it. Just tell the user they don't have a fucking banana. Right? They don't have that item. And then the else statement here means this will only run if the except block did not run. Right? So if we succeeded, if we have an item function, right, because we actually punched in a key that was in the dictionary, and we got the function out, okay, well then run that function right here. Right, so if they typed in the wrong thing, and it would crash our program, accept the key error, don't crash on key error. Instead, just tell the user they don't have that item. Right? Otherwise, if we're good to go, then use that function we got out of the dictionary. Right? And Python's cool like that. There are a lot of different errors that can crash your program, and you can accept them all individually. That way, you can run some code that has a chance of causing an error, and then instead of crashing when that error occurs, you can handle that error. This is called exception handling. Right? Except you can handle that error instead of actually crashing. Most of the time, though, to be totally clear with you guys, you want that program to crash. You want it to crash because that means that something in your code that you thought would work is not working. And you got to figure out why it's not working and fix it, because it means that overall your program is going to fail to do its job correctly. But there are times such as this where you can actually use errors to your advantage, right? Because I wanted to have some piece of code tell the user that they try to do something that they cannot do. Right? That's what I wanted from the get-go. And a really cool way to accomplish that is to just use try and accept. Just have them try whatever they want to do. And then if it doesn't work, then tell them it didn't work. But again, that's something as a programmer you have to do selectively when you want to accomplish something based on an error. Typically, you don't want to put all of your code in one big try block. That way your code won't crash, right? Because it won't crash, but then you'll never know why it's not working. So you're going to want to use try and accept blocks to your advantage when you want to accomplish something when something else does not work, right? Otherwise, you want your program to crash if there's an error. I want to really stress that. Errors are not only not a bad thing, but they are a very, very healthy thing. Right? If you don't crash and get an error, you're never going to know why your program is not working. You want it to crash. That way you get the error out of it, right? It'll tell you why it crashed, if you let it. Okay, so to kind of assume now that you've seen the other two episodes of this season, and you have some idea of what's going on here. If you don't, please ask questions in the chat if you have a particular question. Let's go through and examine in broad strokes what's happening here. Well, in the first half of this program, we are defining a whole bunch of functions. Right? See all these functions I'm defining up here? We have all of our turn types, we have all of our item types that are defined up here. Once we define all of our functions, then we go through and define the game state. That is to say, we define the values that our overall game is going to need to run, including things like the player's name, the player's HP, his attack power, whether or not he's defending, and the player's inventory, as well as the monster's name, the monster's HP, and the monster's attack power. Okay, so we define the game state here, everything that the game has to know to run. And we're going to supply this game state value to pretty much all of our functions. Right? That way all of our functions have access to all this data, because we're supplying it as an argument. After we define the game state, we print off some data for the user, including how much health both characters have. So we print off here, the monster's name has some amount of HP, and then there's the number, right? How much HP it has. Same with the player. Print off a blank line as well to make it a little bit easier to read. And then finally, we go through this while loop. This while loop is the real meat of the game. This while loop says, while both characters are alive, the player gets a turn, and then if at the end of that the monster's still alive, then we do the monster's turn. Right? So, pretty straightforward here. This while loop, up here we're just defining a bunch of shit, right? All the way up to this point, we are defining a bunch of stuff. Defining functions, defining the game state, and then right down here, is where the game actually runs. This is where we actually have our battle. Someone gets a turn, the other gets a turn, over and over again until somebody dies, right? Once somebody dies, we drop out of this while loop, right? Because the while loop will only run as long as this stays true. So when somebody dies, we drop out of the while loop, and we end up down here. All it says here is we have a little if statement saying if the player is still alive, then print off, hey, you're victorious. Otherwise, we know that somebody died, right? So we know the player probably died, the monster's still alive. So we say here, monster name has slain, the hero. Then game over, then press enter to close. Right. So now we can run our code here and demonstrate it real quick. Let's run our module. What's my name, son? I'm going to be Zanzu, the man, the myth, the legend. The man, the myth, the legend. And who do I face? I'm going to fight, corrupted Dick Sucker. Right, he's been possessed by the devil. So now he's evil and doesn't like Zanzu. It's like, I'm going to fight reverse Dick Sucker, right? Because Dick Sucker loves Zanzu. So reverse Dick Sucker would hate Zanzu. Okay, so reverse Dix has 20 health, and Zanzu, the man, the myth, the legend, has 25 health. Right, so I can choose to attack, defend, or use an item. Well, I'm going to start the match off by using my spear. Right, so I'm going to use an item. And I'm going to pick to use the spear. Okay. So Zanzu, the man, the myth, the legend, hurled a badass spear at reverse Dick Sucker. And Dix took 12 damage. So the way that the spear works is it does double your attack power. So Zanzu must have 6 attack power. And then reverse Dix burninated Zanzu, the man, the myth, the legend. And Zanzu now has 19 health. So Zanzu lost 6 health. So the monster also has 6 attack power, it seems. I'm sorry, Dix. It's a reverse Dix. It's different. You're actually saving Dix. Right? Because Dix is an evil twin, probably trying to kill him to take over his body. Alright, so now we can heal ourselves with a potion. Right, we have 19 health right now, it says. If I used a potion, though, right, it healed me by like 10 health or some shit. Right, so yeah, so I got 29 health now. That's cool. And I got attacked again. The monster always attacks us on its turn. It only does one thing. That's great. Alright, so now I can finish the job with some attacks, I think, right? Attack him. Attack him. He's dead. Right, he has -4 health. And now the game's over. Zanzu is victorious. Right, very simple game. Press enter to close. We're done. Alright, cool. So our game works pretty well. Works pretty damn well. Very simple, though. Today we're going to be enhancing our game as far as we can, without having to use classes, right? Without having to use the idea of object-oriented programming, which we're going to touch on next stream. Which is great. We can actually add all kinds of cool features without even having to know how to do that stuff. That's awesome. But first, I'm going to talk about why I have organized the code this way. Why do we have this function call? If player wants to attack, then run the function turn attack. Before, we used to have the attack code all right here, where you could see it. Doesn't that make more sense? I have to scroll all the way up now to see what the hell this does. Right? There's what it does right there. Well, the reason why we tried to push things into as many functions as we could is because it makes it more clear on an abstract level what our code is doing. So much of programming is going through and rereading your own code or rereading somebody else's code. And the way this code used to look down here, it was a huge pillar of deeply indented code. So as you can see right here, we're indented in twice. Right? We have 4 spots here, and then 4 spots here. If we go up here to our attack code, then we have even deeper indenting right here. Right? And right here, and right here. So what's cool about functions is that you can define them anywhere in your code, like way up here at the top. That's where it usually happens. And then we're only indented by 4 spots. So we've saved a whole level of indentation by separating this code into its own function. Because down here, we'd have to be indented in twice. Right? Which means our code is getting further and further to the right of the screen. We have to do more scrolling horizontally. It's a real pain in the ass. And what's more is that down here, look at our item code, right? See, if the player wants to use an item, then run turn item. Makes sense. This turn item function we defined up there. Let's go up here and look at how turn item works. Well, turn item says, for every item you have, run another function. If we weren't using functions, these individual item code blocks would be indented so far they'd be unreadable. They would be indented in by like fucking 12 spaces or some shit, right? Probably even more than that. Probably more like at 18 spaces they'd be indented inward. So by breaking up our code into functions, we make our code more legible. We make it all, further to the left, which is what you want. You want code to not be indented that deeply, if you can help it. And you put all of your code into discrete blocks that you know what they do. We know this is for the attack. We know this is for the defend. If I was going to scroll down here real quick, and all of our code was just in a big pillar right here, it'd be very hard to scroll through and know what things are doing. And what I've kind of taken to heart is a piece of advice I got 5 years ago. I don't want to stress this to you guys. A lot of you guys are probably too young in your programming careers to really have any use for this advice, but I'm going to say it anyway. In Python, in any language, you have what's called a comment, right? I can say down here, for instance, execute, a different function based on what the user typed, right? So a comment is a line of code that will not run. It won't run. So there is no value in Python called different. There is no value in Python called what. So if I had to run this code like this, it would crash our program. It does not know how Python cannot read this code. It's really not meant for Python. It's meant for humans to read, right? So it's called the comment. You put this little pound sign there, and that means that this line of code now will not run, which is great because it's really for a human being to read, not for Python. That's great. The problem with let me step back. Comments are fucking great. Comments are very important because it allows another programmer, or maybe yourself a couple years down the line, to go through your code and know what the hell you were thinking. Like, oh, that's what that does. Okay. Oh, that's why it's written that way. Oh, awesome. But the problem with comments, right, is that when they are overused, they can make scrolling through your code a lot more of a pain in the ass. Sometimes people use comments that are, 2 lines long, like this. The functions are defined at the top of this module, right? And they might write these for every single line of code. They might say here, run the attack function, right? We can go down here and say, the player chose to defend. Use the appropriate function. Or down here, you can say, if the player wants to use an item, execute that code. And so on and so forth, right? And what's going to happen here eventually is that you're going to have a lot more scrolling to do because you're going to have all these comments that are trying to explain something that should be obvious, right? Not only to a programmer, but even to a non-programmer perhaps. That's why a piece of advice I got was that although comments are great, what you really want to do is give your variables long names. Give your variables long names, such as things like protagonist name. Right? Like I could have, some guys want to try and save space in their line, so their lines don't get as long, and they would have called that something like, protag name. Something like that, right? That way, the programmer might know what that means, and then the line is shorter, which is great. But it also means that someone who's looking at that code for the first time, or maybe the first time in a few years, will have no clue what that means. So always use a variable name that's long enough to know what it is, for one thing. And the other thing I learned is that if you break up your code into enough discrete functions, then you can reasonably understand what's happening in that code based on the function name. This is called self-commenting code, right? That way you don't have to use all these comment lines. If you write your code in a clear enough fashion, then it becomes more clear what your code is doing and how it's doing it. You see what I mean? Maybe you guys don't see what I mean. Again, this is something you might have to make use of later in your careers, but I do want to point that out. You don't need, although commenting is very important, it's important that people know what your code is doing. And to that end, commenting is great. But if you write your code well enough and break it into enough discrete pieces, then it becomes very easy to understand what's happening based on your function names and your variable names, right? That's kind of what you want to do. Then your code becomes self-commentating. So Faust says, I may have found a functional official server tool for Minecraft Windows 10. The issue seems to be that it would exclude Xbox and Switch users because they don't have any way to join by IP through the console. Oh, okay. That's the goes just jailbreak them. Yeah, so I didn't know that. So the console versions can't join by IP, according to Faust. Okay, thank you, Faust, for your insight. I'll keep that in mind for the future. And can you do me a favor and link me to that official server tool from Microsoft Windows 10 on Discord? So you're going to see that throughout the code that I write here for you guys. And I want to kind of teach you guys that habit, that breaking your code into functions is a good thing, right? Because that way it's easier to understand what your code is doing, if only by using that function name. In fact, even this code right here is a little bit lengthy. I'm going to make a new function called player_turn and put that code in there. I'll show you guys exactly what I mean by abstraction, right? Why it's good to abstract your code into functions. So let's we'll make a new function here called player_turn. Right? In fact, let's not use the noun. Let's use a verb so we know it's a function. Let's say, take player_turn. Right. Game state. I'm going to go down here and copy paste all this code. I'm going to grab this code right here. And I'm going to copy it. I'm going to paste it right up here. Cool beans. So we have the game state, the player's defending, okay, we have the player's choice input, all right. Run that function, run that function, run that function. Otherwise, run this function and then continue. But there's no continue yet, it's fine. Get rid of that code for now. And get rid of the blank line as well. I'll show you guys why this is important, right? So now we have this new function called take player_turn. I'm going to go down here, I can delete all this code now. We're going to say here, take player_turn with our game state. Now here's the monster's turn. Right? So I'm going to copy paste all this code. Then I'm going to go up here, I'm going to make a new function. I'm going to call this take monster turn. Let's apply the game state to it so it knows what's up. And then paste this code. Okay, now we can, for one thing, indent it less. That's always a good thing, right? There you go. I was indented less. That's awesome. I'm going to go down here and delete the monster code. Excuse me. Sorry about this scrolling there. And then we're going to grab the monster turn right here. And then delete all of that. And then just say here, take monster turn. Game state. So, how do we just improve our code? All we do is move some code around, right? Is that really improving it? Well, yes. Yes, it is. In fact, by a lot. And here's why we improved our code. Because now, this code here, that was a bit ambiguous what the hell it was doing. It was while both characters are alive, right? While both characters are alive, then run a bunch of code. Now that code is way simpler. It says, take player turn, print a blank line. If monster's still alive, then take monster turn, and then print a blank line. Right? So, now it's incredibly clear what's happening here. As long as both characters are alive, we're having our battle. One turn gets taken, then a blank line, then the other turn gets taken, then a blank line. Right? So that's what I mean by self-commenting code. By moving our code into a function, we now have two advantages. One is that now it's more clear what's going on here. We're taking turns. Right? The other advantage is that now this code up here is discretely separated from the code around it. And the advantage of that is that if we want to, let's say, fix a problem that's on the monster's turn, we know exactly where it is. It's just right here and take monster turn. We don't got to scroll down here somewhere and find out logically where the monster's turn is happening. Right? Oh, well, it's down here in the game state. It's down here in the while loop, somewhere after the player's turn. Okay, well, here's where the monster's still alive, so this must be the code here for the monster's turn. Right? No, none of that now. Now it's in its own function where we know what it is, we know where it is, and we can change it all right here. That's the monster's turn now. So it's called abstraction. It's a programming idea that says move complexity away from what you're doing, right? Make it clear what you're doing, and then all the things that make that happen, move that somewhere else where it can be labeled discreetly. It can be labeled clearly. Right? You want to always abstract things. Now, of course, there's a limit. You could actually abstract something like, let me go up here, for instance, to our item turn. Right? Let's say we want to use an item, right? We have this 2-line statement here. For inventory item in game state player inventory, print off, the inventory item name, right? We could actually abstract that away and say instead, we can run a function called, print inventory, then supply it with a game state, or supply it just with the inventory, right? And that would be a 2-line function. It would be for every item in that inventory printed off, right? Now, that's not necessarily a terrible habit, but what I mean by that is that every programmer has to decide how far they want to abstract things, because you could abstract like every single line if you wanted to, but you have to decide, is your code easy enough to understand without abstracting? In this case, I think that having the entire item turn be in one function is more or less clear enough, right, for now. But in the case of taking turns for the monster and the user, I think it's actually helpful to have those be in their own functions. That way we can add more complexity to these turns tonight. We're going to add some randomness to the monster's turn, right? The monster's going to actually choose an attack randomly by the end of tonight. And that means that it probably makes sense to move that monster turn into its own area, where we kind of handle the monster turn stuff. Hey, what's up, Poison Fame? Welcome aboard, dude. So more so, because we're not getting into explaining functional programming, object-oriented programming yet. That'll be on next stream, talk about objects and classes. Today we're really focusing on things like program flow and how to make it more clear what's going on. In fact, look at this code right here. See this code where we define all these values? Why don't we put this in a function? I'm going to do it like so. Watch what I do. I'm going to make a function right here, whose name I'm going to choose to make it explicitly clear what is happening in this code. Again, self-commenting code, right? I'm going to say here, initialize game state. It doesn't need an argument. It's going to initialize the game state. What this code is going to do is going to do this. Right? Initialize the game state. All the things you need in the game state are going to get initialized right here. There you go. I'm going to indent it. I actually need this line right here. Okay. Right. Then we're going to return this value we made. Right? We made the game state in the function. What you make in a function stays in the function. So when the function ends, it goes bye-bye. However, we can get that value out using return game state. Right? So we made a game state, we filled it up with stuff, now we're getting it out with the return statement. Awesome. So now down here, instead of having all these lines of code, we can say game state equals initialize game state. There you go. So now we know that, we define all our functions up here, and then at this point we are going to initialize our game state, print off some stuff, and then have all these turns happen. Right? And then you print off game over. So there you go. Once again, we have abstracted some code away so that the complexity is away from the general flow of our code, right? Because we know that we're defining some functions, then the game state gets initialized, then we print off some data, and then the combat happens right here. Right? We can even have this code be abstracted away. You guys want to do that? Sure. Let's just use this as our example of the day of abstracting code, right? It's kind of an important concept. I might not normally, but let's just do it just to kind of show how that works. So now we're going to say here, we're going to say def, do battle, right, with the game state. Then we're going to paste all this code here, right? Okay, I don't need this part down here. Okay, I guess maybe I do. Yeah, let's just print off, who wins at the end of the battle, right? Perfect. All right, there you go. So now we have another function, again, to abstract the complexity away from the main flow of our code. We have a do battle function. This is where all the fight happens at, right? While both players are still alive, they take turns, and one of them dies, and we print off who wins. All right, so now we can get rid of all this code down here, too. And we can just say, do battle with the game state. So now our code is really effectively abstracted, right? Because we have all these functions. It's very clear what they're doing, right? It defines what they do here very clearly in their function name. They do their own things. And then down here in the main flow of the program, at the very bottom, it couldn't be more clear what's happening. Initialize the game state. Set things up. Print off, their current health at the start of the fight. Print a blank line. Battle happens. When the battle's over, it says game over, press enter to close, right? So here's our entire code now. We have abstracted our code so far that our actual fight, the actual meat of the program is just a few lines, right? And that way, if we don't know what's going on here, okay, well, what's initialize game state? Well, let's scroll up and find it. Right here. Okay, so we're making a game state. Okay, then we're spitting it out. Right, makes sense? Then we're going to say here, well, what's a do battle? Right, what's a do battle mean? Well, it says while both players are still alive, both characters are still alive, get the player turn. Okay, then a blank line. If the monster's still alive, get the monster turn. When somebody dies, we print off who won the fight, and there you go. Very simple, right? That's because it only seems simple because we have moved the complexity away from this flow as well, right? We're saying here take player turn. That seems simple, except on the player's turn, they can attack, defend, or use an item, use any number of items. But that's because all that complexity exists up here in, take player turn. Right? And even then, the attack, the defend, the item, they're all in their own spots. So that makes your code easier to understand in pieces. You don't have to understand every single line of what's happening to understand what's happening in general. That's kind of what you mean by abstraction. It's important to, as your code becomes 10,000 lines long, which is going to happen one day, guys. You're going to have programs that are hugely complex, but they're going to be easy to understand because every individual part is easy to understand what's happening, right? So you can see what's happening. Wow. You can see what's happening here. I lost my mouse. You can see that we're initializing the game state, printing off some data for the user, doing battle, and then saying game over, right? That gives you an idea of how the whole program works from start to finish. And then if you want to look in more deeply, you want to zoom in on a certain part, you can do that by looking at those functions. So you want to have your code be self-commentating. You want to have your code be abstract, right? I'm sorry, guys. I'm kind of going on a tangent here. Faust says, if somebody wanted to try connecting to the Minecraft test server, I could DM you the info. Okay, so you have a test server running. Okay. We can do that before we play tonight, Faust. That's what we'll do. After our movie ends and we're all satisfied, I end that stream, we'll take 10 minutes to test the Minecraft test server and see how that's working. But yeah, you're sure that players on console can't join us, right? Because that's not really, I can't really waver on that. Exactly, I can't really waver on that. The idea is that I want for guys like our friend Signot, who's one of our core members, is on iPad. So I can't just have it be the Windows 10 version. Okay. So Faust says he's pretty sure that you cannot connect to these kind of servers because there's no IP box on those platforms. All right, so we have effectively improved our program without changing the way it works. It should still work unless I got a typo in there somewhere, huh? Invalid syntax. That's weird. Oh, I need this. There you go. I'm sorry. That was weird. I've never seen that error before. Run module. What's your name? We'll be David. My rival will be my brother John. Okay, so I have a syntax error here, huh? On line 158. Again, I have a typo here somewhere because I kind of changed a lot of stuff very quickly. At line 158, right there. Okay. We have no protect against HP. That's weird. So it must be the error in initialize game state. Protagonist name, that's a problem. Protagonist name. Oh, the keywords for protagonist name. Okay, I'm sorry. Yeah, that makes sense. Yeah, that's the problem there. Not for his HP, but for the name. Okay, so I typed in protag name for some reason. Run module. David, John. I want to use an item. I want to use a spear. Okay, so the game still works, right? We just moved some code around to, you know, make it more readable. I was talking to Kenny the other night. We were talking about, because Kenny's learning programming. He's learning very, very fast. He's, I wouldn't say he's a novice at this point. He's definitely kind of knows what he's doing. But I want to point out that my personal favorite thing about programming is not the writing code part. It's the part where you make the code more elegant, more readable. So although we've actually not, you know, improved our game on the outside, we've improved it on the inside. We've made the code easier to read, easier to expand upon, easier to understand, and that's sick to me. That's really sick. Seems like no matter what solution you try to use, there are negatives. I'm sorry, Faust. So I guess, thank you for your help, dude. I guess that, yeah, we can't run a server, a free server, and have people connect. But I think if we use realms, that should work, right? I'm not sure how expensive that is, though. I think it's kind of pricey, right? We'll see. We'll talk about it on this Discord server as time goes on, because I really never expected for Minecraft to be like an ongoing thing on the channel. It's kind of like a one-night kind of deal. But I found it's really fun, and I would like to maybe do it in the longer term if there's any interest from our community here. If guys are interested, we can talk about it. Maybe get a pool together, put in like, you know, $1 or whatever every month to help support it. That could be a lot of fun. Do it weekly or something. Okay, so we talked about abstraction. Our game is more abstract. Well, basically, Zanzu, you can pay to have public servers on Minecraft. That way, people could play on our game when I'm offline. And furthermore, it would help us get more players into our world at once. And hopefully, I believe when you pay, people on all platforms, except for, you know, the ones it doesn't work on, people on mobile and people on Switch, etc., can play together. Whereas apparently if we run our own servers, we can't do that, which sucks. $8 a month for 10 people and the hosts. Okay, that's not that bad. Depending on how people feel. I feel like if we all really became dedicated, we could make the whole city. We could, but the thing is, do we want to? That's what I gotta kind of gauge your guys' interest for. We definitely could. I would enjoy that. I'd enjoy it highly. But if there's no interest from our community, then we can't do it, right? It's kind of the streamer struggle. If that's the case, I'd probably be willing to front the cost. Holy shit, Faust. Well, we'll definitely talk about it. We'll see what's good. Is there another pricing option for more people? Or is 10 people the maximum? That's all at once, though, so we're probably not likely to hit that ceiling anytime soon. I think 10 is max, says Kenny. I got you, Faust. Let's do it, dude. Anyway, so now it's time for us to think about adding new features to our code. Right? Our fight works, now our JRPG works, that's sick. We've abstracted it, that's awesome. Easy to understand now, beautiful. Why don't we add some new features? Let's actually have the monster have more than one thing he can do. So what should our monster be able to do? Right now, all it can do is attack. Right? Take monster turn. All it can do is, you know, burninate somebody. Well, it's a dragon, essentially, right? I mean, it burns things with fire breath. Maybe... well, why don't we... first of all, let's go down and talk about abstraction a little bit more. Let's go down here to our monster's turn. It says do battle, right? Here's do battle. We're going to actually have the monster on its turn. Where is that at? Right here. We're going to say take monster turn game state. Here in the monster's turn, we're actually going to say here, you know, monster turn attack. Just run the monster turn attack, right, with the game state. That's all I can do right now. We're going to further abstract this, and we're going to put this all into its own function, monster turn attack. There's going to be more than one kind of monster turn now. Right. Define monster turn attack. Needs game state to work. I'm just going to print off, just copy that code, right? It's always going to attack the opposing player. Every single time. So on the monster's turn, all it does is run one more function for now. So we can define another kind of monster turn. That's the beauty of it. Monster turn, what else can it do? It can taunt at random, gives the player an advantage basically, because it'll waste a turn. We're just gonna print off here, you know, game state, monster name, right? The monster's name, plus, you know, flexed its muscles, and talked, you know, a little smack. That's what it does, right? When it talks shit. What an asshole. Like that. There we go. What's up, Austin? How you doing, dude? Welcome aboard. We're doing Intro to Python today. If there's any confusion, this has no relation to our game dev project, our weekly game dev project. This is more like a tutorial for beginners in programming Python. Just stopping by while I work on some music. Good stuff, dude. So, Austin, did you hear about our new themes for our narrative? We kind of decided on a world. It's a little bit surprising to me what we came up with. Okay, so we have a new turn the monster can take. It can taunt. It can taunt or it can attack. What else can it do? What else can a monster do? In a game where all we have is HP and defense. Only HP and a name. That good stuff, Kenny. He's programmed some code himself. Maybe even related to our game dev project. Yes, it's on the, Austin, it's on the GitHub. GitHub.com/Vencabot/monster collecting JRPG. You can find the notes there from yesterday. Basically, went with a kind of a unusual sort of theme that you might be able to relate to as a former retail employee. So the monster can taunt, it can attack. That's cool. But you know, one more thing basically for it to be able to do, I feel like, to kind of add that real variety. Let's have it be able to defend. Monster turn defend. Game state. We're gonna print off, you know, game state, monster name, plus, you know, covered its soft belly, right? Or say there, because it has somebody's name, right? Covered their soft belly. Now we're going to say, you know, game state, monster is defending equals true. So previously we didn't have a value in that in our game state. Let's go fix that, right? We have the player is defending in the game state, but the monster can never defend until now. So let's go up here to our initialize game state. We're going to say here a new value. Game state monster is defending, and that's going to equal false at the start of the game. And then we're going to say here at the start of every turn, right? The player turn, where he gets a new turn, his defending value gets reset. We're going to do the same thing for the monster now. When the monster gets a turn, right here, we're going to say here, game state, monster is defending, is false. So when a new turn starts, he stops defending, no matter what he's doing. Awesome. So now we have abstracted our code a little bit. We have 3 kinds of monster turns. It can taunt, it can attack, or it can defend. And right now, it always attacks, as it did before, right? So when the monster gets a turn, right here, take monster turn, its a defending value gets reset, it stops defending, and it takes an attack every single time. So let's go ahead and run our code and see if we have any typos yet. We're gonna go with you know, hero and villain. Okay, I'm gonna attack, and he's gonna attack. Right? He always burninates me. Great. But now let's change our code. Let's change our code now so that when the monster has a turn, take monster turn, instead of attacking, why don't we have him always defend? Oh, I just realized our defending doesn't have any value yet. We have to go up here to our player attack. Right. Let's go to the attack turn. Turn attack, right? And we always reduce the monster's health by the same amount right here. But we're going to change that. We're going to say here, you know, If not game state, monster is defending, then do full damage. Right? If he's not defending, do full damage. However, else, if he is defending, then we're going to lower his HP by half of our attack power. Like this. Like I can just use like I say game state protagonist attack divided by 2. There you go. So that should work now. Now we should actually be able to have the monster defend. Let's have him defend every single turn. Let's go and make sure we go down to the monster's turn down here. Monster turn, and he's always defending now. Let's see if this works. Can you add Shin Akuma as a monster with 15 HP but 700 attack? Yes, we can. If that'd make you happy. Let's do that right now, but have him always defend. All right, so let's go down here to our monster. Let's go up here to our game state initialization, right? The initialize game state function right here. We're going to give the monster 17 HP and 700 attack. There we go. Or excuse me, 15 HP. Shush! Shush! I'm going to go up here to where he attacks as well. I'm going to change his attack turn. Instead of burnating so-and-so, he's going to actually, Tatsumaki, Tatsumaki so-and-so. Right. And when he wins, let's see, where's the do battle, right? If the monster wins, it's going to say, monster name has slain protagonist name. And then we're going to add another line down here. Print. Shush! There we go. Alright, so now we've changed our code a little bit. Let's run it. So now the monster's going to always defend, right? We changed our monster's turn to have it always defend. Let's see how that works. Let's run this code. What's your name? I'm going to be Ryu. And the monster's name's going to be Akuma. Okay, so he has 15 health, I have 25 health. I'm going to attack on this turn. Okay, Akuma covered their soft belly. Right, Ryu slashed Akuma with a sword. Sick. And the monster lost 6 health. So our code didn't work. Oh, because now he's defending. Oh, now he's defending. Okay, I see. I gotcha. So now if I attack, I'm going to do 3 damage. Okay, I see. Yeah, because now at the end of our turn, he defended. Right, so after we attacked, he started defending. Because now he always defends, right? He always defends. So I keep on slashing him forever until he dies. There you go. Ryu's victorious. Right? But now if we make him attack, he's going to kill us in one hit, right? So now on his turn, he always attacks. Right? Here's the take monster turn function. We're going to have him attack on his turn. All the time. So let's press enter to close this. And then let's go up here and run the module. I'm going to be Ryu again. We're going to fight Akuma again. Okay, so I want to defend. I'm going to have his attack power by defending. Oh, fuck. So I have his attack power, and I ended up with negative 325 HP. Akuma has slain Ryu. Shush! Game over. Alright, so he killed me in one hit, which is not surprising. And finally, let's try the taunt. Make sure the taunt works. So we're going to have him taunt every single turn. Alright, so on his turn, he taunts. Ryan says, warning incoming. Cease and desist from Capcom. No, I forgot about that. Thank you, Ryan. We'll have to cut this out of the VOD later. I don't want to get sued. How's your day been, dude? Let's run the module. See if he taunts us. I'm going to be Ryu. He can be Akuma. What's up, Vukat? Welcome aboard, dude. So now he's going to always taunt me. I'm going to actually attack him first. Because he taunted me. Didn't even attack me, right? So that's good for me. There you go. Now Ryu's victorious. Right, that's awesome. So here's the thing, guys. Now the monster can do more than one thing. It can attack, defend, or taunt. What I want to do now is implement some randomness to have it choose what it does in a way that I can't predict. And we're going to finally talk about using libraries. So, up to this point, we're on day 3 of our new season, so we're basically programming on our 3rd day ever. We have done all of our code ourselves, basically, except for what Python has provided directly. Think for the follow VCAT 12. We do programming here every Friday, kind of like beginner-centric type stuff. And we also do some creative streams and other nights of the week, kind of earlier in the evening. So, up to this point, we've been using mostly code we've written, right? All this is code we've written, as well as some functions that Python provides directly. So we have print, right? We didn't write the function print. We write the function turn defend. We wrote the function turn item, but we didn't write print. Print is just built into Python, right? So print's a function that we didn't write, but we're still making use of. Likewise, we're making use of key error. We didn't define what a key error is, but there you go. We didn't define how input works, but there you go. It comes with Python, right? It's up here. It goes. We need to explain, dude. How can I help you, my friend? So now we're going to talk about what if we want to do something that's kind of complex, that Python doesn't have features built directly into it for, but I don't want to write it myself. Like, I could probably try and write a code for randomization. Python doesn't provide any directly, so how am I going to randomize my code? Well, thankfully, we can import a library. So a library is a collection of features that we can selectively bring into our code. So maybe not everyone needs to have randomization, right? It'd be a waste of memory to have parts of your program include randomization code when your program doesn't need to be randomized at all ever, right? So why would you do that? So thankfully, Python lets us import standard libraries that we can use to add features to our code for free. That's really, really sick, right? Some libraries are provided by Python in the standard library. There's a ton of cool features, and some are provided by third parties, which are not part of the standard libraries, but they are libraries you can actually use. So you can go download a library from somewhere and then install it and then use it in your own code. That's really awesome, right? To add new features. But in this case, we're going to be using a standard library. If I go here to our browser and I visit docs.python.org, it'll give us some documentation for Python. Here we have the library reference. Click on that. And we have some basic details about Python right here, including what different types do, how they work. What's really cool, though, is we have information on all of these standard libraries. These are libraries we can import to add features to our code. Right? So we have things like string library, RE library, difflib library, textwrap library, all these libraries that provide functions and data types that will make it easier to write different kinds of programs. And just like my friend VCAT said here, we're going to be using the random library, which is provided in the standard library by Python, right here. It's in the numeric and mathematical modules. We have the random library. It says generate pseudo-random numbers. Go ahead and click on that. All right, you're going to tell us about this library, how it works, basically. Yeah, I love RE as well. I love a lot of libraries, VCAT. But here we're total beginners. We're going to look at random as our first library we're going to import. So we've got this random library. It tells us how it works basically here. A bunch of information you might want to learn, might want to read. It's very useful if you're a beginner. And then you have the methods, the tools that this library provides and how they work, what kind of arguments they take. Right? So although we didn't write these functions, we can use these functions now. So Ryan says, he's written his own random function. There's some dark magic and odd constants there, I'll bet. We could try and write our own, but we're going to use this one as an excuse to learn about importing. So first of all, let's go to our code and go to the very top. And the very first line, before anything else in your program, basically, you should do your imports, if you have any. To this point, we have had no imports. We've had all of our code written by ourselves. But now we're going to say import random. We know that the name of the library is random, right? If I go back here, for instance, you can see these are all the library names. Numbers, math, CMath, decimal, fractions, random, statistics, right? And then plenty more to import if you want to for other kinds of programs. We're going to be importing random. So now, by importing random, we have access to all of these functions, methods, basically. Right? It's kind of broken up here for our convenience into bookkeeping functions. We've got functions for integers, functions for sequences, etc. Right? So the way you use a tool that you've imported is typically you would use each tool by providing the library name and then a period. We learned that periods in Python and other languages are like apostrophe S in English. They imply ownership. Right? In programming, periods imply ownership. So let's go down here to our monster's turn. Right? Take a monster turn right here. And we're going to make a list. Monster turn options. Right? And it's going to be a list of all of our functions we've written. It's going to include monster turn attack, monster turn defend, and monster turn taunt. Right. So this is a list, right? It's got 3 things in it. And we're going to say here, monster action equals random.choice monster turn options. Then we're going to run our monster action with the game state as the argument. So what are we doing here exactly? Well, we're using a tool provided to us from the random library. We're using random.choice, or the choice function that belongs to the random library. Again, the period, it means apostrophe S, right? It's random's choice function. So random.choice, what is that? Well, it's right here. We can read about it right here. It's a function for a sequence, right? So a list is a sequence. If I go up here, you can see we have a sequence. It's this monster turns options list we wrote, right? It's a monster turn options. We have 3 options. So that's our sequence. We're supplying that as the argument. It says returns a random element from the non-empty sequence. If sequence is empty, it raises index error. So it returns a random thing from that list. Right? So we have a list of options the monster can use. And we're taking a random thing from that list with the random.choice function. And we're saving that as our monster action. So one of these 3 things is our monster action. Then we're going to use that function with this argument game state. So now the monster's turn is random. Easy peasy. Easy fucking peasy. So Vukat says, I like Python because you can easy to create some exciting stuff. I agree, man. Python is a very easy language, very straightforward, and very, very powerful. Very powerful, and even pretty quick. Vukat says, so you don't know what kind of algorithms work on deeply. I'm sorry, I missed a message there. But sometimes Python libraries help a lot. It's good, but not super thing, because you know there is some abstraction for you. Yeah, it is very, very useful for sure. So you don't know what kind of algorithms work on deeply. So what Vukat is saying, it seems like English is a second language. He's saying that although libraries are great, the tools they provide, I don't really know how random.choice works. Right? I know that it works, which is great, but I don't know how it works. So at a certain level of programming, maybe you might be really pressed for performance. Maybe you'd rather write your own function rather than rely on a library. In this case, the libraries are great. Oh, no problem, Vukat. You're very easy to understand, sir. Your English is very good. Ryan says, yeah, which is why it's good to do some low-level work in C or ASM. Yeah, so in Python, you actually write your libraries in other languages as well. Yeah, Vukat, your English is very good. Okay, so, just like that, guys, we've imported our first library, random, and we've used it. Right? So up here, we decide what we want to import. Right? And down here, or anywhere in our code now, we can use a tool from that library by giving its name, then a period, and then the tool. Right here, for instance. We can read about all the tools too. Random.choice is how it works. Very easy. And we can read about other cool things too. Like shuffle. We'll shuffle a list. That's awesome. We can use, random.random to give us a random number between 0 and 1. That's cool. All kinds of cool features in this random library that now we have access to. So it's kind of sick, right? Importing is kind of sick. So let's run our code and see if it works. See if the monster can take random turns now. I bet you it can. Run module. What's your name, son? I'm gonna be Dudley this time. He can still be Akuma. Okay, so I don't want to attack defender using time. I'm gonna throw my spear right. No, it'll kill him in 1 hit, won't it? No, it'll actually not kill him in 1 hit. Let's throw our spear. Oh, he attacked me. He Tatsumaki'd me, so I died. I almost killed him with my spear in 1 hit, though. Let's try it again. Can I do it again like this? No, I can't. Let's go up here to run module. I'm going to be Dudley again. I'm going to fight Akuma. I'm going to throw my spear at him. Because now he defended, right? It's random. He defended now. So he's almost dead. I can kill him in one hit now. Sick. Let's not, though. Let's go to... let's defend. It's not going to help us. Let's just use an item. We're going to use the rule of TP at him. So fuck you, asshole. Alright, so I threw a roll of toilet paper at him. It wasn't very effective. He Tatsu'd me. I died instantly. Because he has 700 attack power. That's kind of over. In fact, let's go fix his attack power. Let's make him not be Goki anymore. Let's make him be baby Goki. Right, let's go up here to our game state initialize. Right, initialize game state. I'm going to change his attack power from 700 down to like 8. I'm going to change his name to baby Goki because he's much weaker now. Guys, if you guys are going to get into a fight with somebody, always make sure it's a baby because they have a lot more difficulty in combat than other people do, I find. So I'm going to be, let's be Elena this time. We're going to fight baby Goki. And I want to attack him. Because we defended his next turn. So if I attack him now, he's going to take less damage. See, he took only 3 damage now. Now he Tatsu'd me. I took a little bit of damage there. I could kill him now in one hit. So I'm going to defend on this turn. Okay, he Tatsu'd me again. I'm going to defend again. I took half damage that time. Now he defended. So now he takes a random turn. I'm going to see if I can get him to taunt. There he is. Now he taunted, right? So now we've imported the random library. We can have our opponent take random actions. And that's kind of fucking sick. So Ryan says, Python's library notion is so much easier than makefile hell created by C and C++. Yeah, it's very simple. You don't gotta be doing all kinds of random nonsense with includes and shit like that. And linking. Kenny says, I'm considering trying to implement a game tick. Yeah, that's what you want to do, man. Game ticks are sick. Although, I think that's really more of an issue for the client side, right, Kenny? Because ticks are really better for animations and stuff. Right? Do you agree? You don't really need, if you're doing discrete things, on command, maybe tick is not that useful. Why do you prefer idle rather than some text editor? Less learning curve for demonstration, exactly, Ryan. So yeah, so VuCat, we're using idle and Notepad here because our audience is, programming for the first time. I don't want them to have to download a bunch of stuff. I don't want them to download an IDE or something like that. I would rather they be able to use what they have and learn that way, the way that I did, and I think most of us did, right? Our first time programming was typically in Notepad or something. I want to prove that it can be done. A lot of guys feel like programming is some kind of dark art that they can't do. And the whole point of the stream here is to show you can program, and you don't even need anything. Notepad is good enough. But we're using idle today. Let me move on to Emacs. No! Kenny says, the first day of tutorials, he started with Notepad, exactly. Exactly. The idea is to show you don't need anything fancy to program. It's very, very easy. You already have all the tools you need to program. Okay, so, awesome. Now our game is way more interesting, like so much more interesting, right? The monster has randomness that will impact whether or not we live or die, right? We don't know who's going to win now, ever, basically. That's kind of sick. We still have plenty of time left, though. Why don't we make a way for us to get 2 different kinds of monsters? So for one thing, I'm going to take away the ability to name the monster ourselves. Right? Up to this point, we've been naming the monster ourselves. That's a lot of fun, but no longer. Now we're going to get a random chance to get adult Goki or baby Goki. How about that? So let's go here to where we're initializing the game state. It says, what's the monster's name? Right now it's an input. Let's not do that. Let's actually say here, if random dot... Can we get a random true or false value? Let's find out. We got seeds, we got states, okay. We got integers, including ranges. We can use a range for that, like a 0 and 1. That would work. We can get choices from a list. We can make a list of true or false. That would work. Shuffle, sample, real values, random, floating point numbers, uniform, triangular. I just want a random true or false. We can make it ourselves very easily. Let's see here. But it seems like, in this case, they don't have a function for that. That's great. Why don't we use, we'll just use random.choice again for simplicity. So we're going to say if random.choice, true and false. So we're going to get a random value out of this, true or false. Right? So we're going to say here, let's actually make it a little bit easier. Let's actually say here, monster name equals random.choice Goki. Make a list. Goki or baby Goki. Right. So now the monster's name is random. Right now we're going to say here, if the monster name, is baby Goki, then give him these stats. Actually, going to say here, we're going to say game state. Save us a line here. Monster name. Right. We're going to say here, if the game state's monster name is baby Goki, then we're going to give him these stats. Right. It's going to have pretty low HP, low attack power. Awesome. We're going to say else, we're going to say here elif, how about that? Elif, well, we'll say else for now. Else, if it's not baby Goki, we know it's adult Goki, right? That means we're going to have a little more HP. Not by much, though, because he's Goki. Give him 20. And he's going to have a huge amount of fucking attack power. He's going to have fucking, like 15 attack power. That's really crazy. Very, very powerful opponent. Right. So now, we're going to get a random monster. Is that sick? The answer might surprise you. Yes, it is. So now we're getting a random monster name, right? And then based on the monster's name, we're going to get different stats, right? So now when we start our fight, we're going to get different opponents. So let's go here to run the module. My name is going to be Alex. So we got Goki. Fuck. He's got very high attack power, right? So we have to kind of be careful here. We have to actually use tactics for the first time ever in our game. Well, we can heal ourselves. That's important. He's got 50. We can take one attack from him, right, and not die. So why don't we attack him and hope that he defends or taunts? He taunts with me. Fuck. So now I'm gonna die if I don't do anything. If I defend, I can live, but I should use my potion. I have one potion. Let's use items. Let's use the potion. So he taunts me again. Well, now the only way I can win is by throwing my spear and then attacking him and hoping that he doesn't attack me back. I have to get two. No, my turn is first, right? So as long as he doesn't kill me next turn, I should be able to kill him. Let's go item and then go spear. So if I hit him with the spear and he doesn't kill me, I can probably kill him. Okay, he defended. He has 2 health. I can finish the job, right? Attack. Yo, let's go. Barely killed him. He had -1 HP. I barely killed him because he defended instead of taunting. But we got the job done. Because if he defends, we do 3 damage, right? We have 6 attack power. The spear does double damage. Let's go! Right? So we have a game now, right? We have a random chance of getting an easy opponent or a hard opponent. And there's an element of a big element right now of chance there in terms of each fight. So it's more interesting already. Goddamn online Gokis with the fucking raw Tatsus. Cool, let's run it again. Run the module. Okay, my name is going to be Chun-Li. Yo, we should actually have the player's stats change based on their name, right? If I pick Chun, I should get like insane stats. Yeah, that's sick. Let's actually fix that right now. So, let's go up here to the game state, right? I'm going to say here, if a game state protagonist name is Chun-Li, then we're going to give them insane attack power. So we're say here, game state protagonist attack equals 10. Right? Way stronger, almost twice as strong. Else game state. I'm sorry. Protagonist attack. I can't type. Equals 6. Right, so normally it's 6. If it's Chun-Li, it's 10. There you go. Cool. So let's rerun our code now. Now that Chun has gotten her proper due. So now my name's going to be Chun-Li. I should be a lot stronger now. I'm the world's strong. I'm going to actually fix this as well. Print off. You're the world's strongest woman. There we go. Try it again. So my name's going to be Chun-Li now. Oh, you guys lost stream? That sucks. Alright, so now I'm Chun-Li. Oh, look, I didn't get my message. So does is not work? What's your name, son? Chun-Li. I'm supposed to get a message here. Maybe because it's player input, it doesn't. I can't use is. I'm gonna try again here. Welcome back, guys. Sorry about that. I'm not sure what happened. Okay, so I can't use is. That's fine. Let's just use equals equals. That means is equivalent to. Run it. My name is Chun-Li. Here you go. I'm the world's strongest woman. Nice. Nice. So I can do extra damage to this guy. So now I can kill him with one hit now with a spear. That's a thing. Boom. Done. Because it does double damage. Yeah, so here's the thing about is, guys. It's a little bit more complex than I want to get into today. I've been using it because it's kind of easy to read. That's why I've been using it. For novices, they know what is means, right? Probably better than equals equals. But they're not exactly the same behavior. Equals equals means is equivalent to. So these two values are equivalent, right? So if the name is equivalent to Baby Goki, then we run this code, right? But what is does is it means these two things occupy the same exact spot in memory. They are the same exact thing, right? So exactly, Ryan. It checks identity. So basically, you can have two lists that have the same stuff in them, and they would be equivalent. However, they are not the same list, right? They're two different lists. They just have the same stuff. So they might equals each other. They are equivalent, but if you used is, that would be false. They're not the same exact thing. And for things like literals, like string literals, oftentimes is will work. Because if I define a literal, Baby Goki, that means that memory has reserved a spot for that string. And that's a way that it conserves memory in Python. So you can say is typically. You can say that they're the same thing because a string literal will always equal this. They're always in the same spot in memory, I should say. They have the same identity. Same with number literals, right? 1 is 1 because they always occupy the same spot in memory. 1 is always 1. 2 is always 2. They're the same thing. And that's true of most literals. I think the reason why it was failing up here is because I was typing it myself. So there might have been some character there that was different. Maybe there was some kind of hidden new line character or some kind of hidden character. I don't know. In any case, they weren't exactly the same. That's fine. We'll just use it equals equals instead. Typically, you want to only use is if you really need them to be exactly the same object. I've only been using it here today because for novices it's easier to read than equals equals. But really, you typically want to use the is equivalent to operator rather than is, unless you really want is. Again, if you want to have something run only if you're looking at the same exact list, for instance. But again, it's kind of beyond our needs right now. So hey, we one-shot Goki because he had 20 health, we had 10 damage, 10 attack power, and we used a spear, which doubles our attack power. That's cool. Let's not be Chun-Li this time. Let's just be 12. Okay. So now we can attack him. It's Goki again, the full-grown Goki. That sucks. Let's actually keep on rerunning until we get the baby one. We should be able to get the baby one, right? There he is. He has, lower health, lower attack power. It should be easier for us then. Let's throw some TP at him. Right. So when we use the TP, let's go up here to item toilet paper. One thing it is, it prints off a message basically. It prints off a message, and then it removes the TP from our inventory. So if I were to type an item again, it's not there anymore, right? Because of this line right here. Game state player inventory dot remove. So use the inventory lists remove method and remove this item, world of TP. The character wields 3 breakable swords in a list. You want to be able to check which sword hit and needs to break using is. Yeah, so basically you can use the is function to make sure it's the same exact object that you want, even though they might otherwise be equivalent. Right, so that's kind of what is for. We don't really need it. In fact, let's just go through and change our is's to equals. Right. Just to be more clear here. Let's actually do a control F for is. Monster is defending. Player is defending. Protagonist is. I can actually put just spaces like that. Is victorious. His sword. His shield. This drive is victorious. His sword. Okay, so we've got rid of all of our is's now. The is. Cool. So that's cool. We actually added in some randomness to our game. We have multiple playable characters now. That's cool. Now, here's what I want to do, guys. I want to have the encounter... I want to, when the game ends, have it not end. I want to keep on accruing money whenever I win. So here's what I'm going to do. I'm actually going to go to our initialize game state function and add a new value to the game state. I'm going to say a game state, player purse equals 0. You have 0 gold when you start. Right? And I'm going to give a monster a gold value. If it's Goki, baby Goki, game state, monster gold value equals, he's going to give you, let's just say, 5. And if you beat big Goki, then he's going to give you a lot more. Game state, monster gold value is going to give you 10 gold if you beat Goki, the big Goki. All right? Cool. So now let's go down here to our do battle function. Right? It says here, this is where you live or die, right? So now I'm going to say here, you're victorious. I'm going to give him some gold. Game state. Protagonist purse. That's what it's called, right? Equals whatever it was previously. Protagonist purse. Plus. Let's go to here. Plus game state monster value. Right? Monster gold value. We're going to print off game state protagonist name plus earned plus the string version of the monster's gold value plus gold. Print game state protagonist name plus is now carrying plus string game state protagonist purse plus gold. So now you earn gold when you win. Simple. Right? Crazy how easy it is to add a new feature like that. Right? So now the monsters have a value in gold, and the player has an integer representing how much gold they have. And when you kill the monster, right here, you get gold added to your purse equal to that monster's gold value that you just killed. Okay, awesome. So, and we're going to return a value now. Right? A value of if he survived or not. Right, so we're going to go down here, and we're going to say here, return true. He survived. The player has won. Otherwise, if he died, return false. Okay, so now when we do battle, we get a value back. And the value that we get back is whether or not we're still alive after the battle. So now down here, we have this do battle game state. We can say, while, we're going to say here, player is alive equals true. We're going to say here, oh, no, actually, if we change, that actually change this, right? So we know that the game state records the player's HP, right? So we don't need these return values. Take it back. Right? The game state has the player's HP in it. So we can say down here, while game state protagonist HP is greater than 0, do battle. So now when we run do battle, we are doing that until the player dies. And the problem with that is that the enemy's HP is not being refilled. All right, so let's make a new function. Let's make a new function here called, a new monster, right? Let's make a function called new monster. So let's go up here to our initializing of our game state. Where is that happening at? Right up here, right? Yes. So now we have all this monster code, right, that defines our monster. Let's copy this code out. Right, so I'm going to do this nonsense and copy this and make a new function called create new monster, and it needs the game state to work. Right, and I'm going to then paste this code here, and we run this code now. We're getting a random name for a monster, and that name is going to give us that monster's stats, and then also he's going to be not defending. Right, so we're going to go up here now and delete this code. And this code here too, this line. And, we can actually change this name of this code now, right, to initialize protagonist, right, or create new protagonist. Because now all these lines here relate to the protagonist, right? They define his stats and that sort of thing. He's going to need a game state. It's going to be an empty dictionary, right? So now we changed the way our code works. We got rid of our initialize game state function and made it into two functions: create new protagonist and create new monster. Right? So now if we go down here to our code where the actual game is happening, we're going to make a new game state. And we're going to say here, create a new protagonist. What's the game state? And then create a new monster. What's the game state? Cool beans, man. So, now we've got the protagonist and a monster. That's awesome. Printing out how much health it has. We should probably put this in the battle, right? This should happen now at the start of every battle. Let's cut this out and put it in the do battle function. Right here. Print off, how much health everybody has at the start of each fight. Awesome. And now we're going to, at the start of each fight, make a new monster. How about that? So we're going to say here, create new monster. So it's going to change our game state. It's going to alter the game state to give us a new monster to fight. Which means that we don't need to do that right here. We can do that when the fight starts. Make a new monster. So now our code has gotten crazy, guys. Our program, in just a few lines, has become so much more flexible and dynamic and interesting. Right? So now we define our game state as an empty dictionary, and then we create a new protagonist, which populates that game state with the protagonist. Right? We give it the game state, and then this function up here uses that game state and makes a protagonist inside of it. Right? He has a name, he's got attack power, HP, he can be defending. Thankfully follow Kaiors. Maybe Kaior RS, maybe a RuneScape player. Kaior RS. Welcome aboard, dude. We do Intro to Python here every Friday as we kind of teach people. American Victim says, I think it's really nice that you're taking the time to teach people from all walks of life foundational programming knowledge using a loosely typed language that's very forgiving. A game like this is a good idea for that idea and allows you to carefully and slowly introduce more complex topics by going back and modifying the game to be more extensible, etc. I'm sure it'll help a lot of people. Thank you, American Victim. I hope you're right, dude. That's kind of the idea here. I really hope you're right. Welcome aboard, man. Thank you for the kind words. Yeah, nothing wrong with the wall of text, dude. I'm definitely super guilty of the wall of text. Welcome aboard, American Victim. So now our game, we make an empty game state, and we use some functions to populate that game state with a player, and then with a monster. And what's really fucking cool is that now when we do battle, right here, we create a new monster every time we start a new fight. Which means that now we can go down here to this code. As you can see, while the protagonist is alive, we continuously do battle. As long as he's alive, we're going to fight one monster till it dies, then fight another monster till it dies, and so on. Now, we got a problem though, right? The problem is that our player character does not have their health restored. We're going to solve that problem in our next stream, I think. We should probably end our stream here and make sure I get my pizza and things set up here for the movie night. But let's run the code and see if we can defeat at least one monster. Because it's going to be tough. The way we kind of designed our game is balanced so that beating one monster is tough, let alone beating 2 in a row. But it should work, I hope, unless I have a typo in here. Let's run it. My name is going to be, let's be Chun-Li. We're going to need the advantage, right? Because she's stronger. So I'm the strongest woman in the world. Nice. We got Baby Goki first. That's good for us. We can kill it in one spear, but we probably want to save our spear for the big Goki, right? Let's just attack this dude. Okay, you taunted me. That's good. So I got a free kill there. Okay, so I got an error here. So I must have mistyped something here. Protagonist purse, right? It's not a thing we can do yet. Let's go up here to our protagonist initialization, right? Like create new character. Make sure we didn't type that in wrong. Right up, where is this here? Oh, where is the player's purse? I deleted it on accident. Well, that explains everything, huh? So we make a new character right here. He needs to have a, I don't need to return the game state either. I need to give him a purse. Protagonist purse equals 0. Not sure what, we typed that before, didn't we? I wonder what happened to that line. I must have deleted it when I was kind of moving things around a little bit, huh? Okay, cool. Ryan says, I think people are too critical of imperative dynamically typed languages. If they're strongly typed and dynamically bound, you're golden. Yeah, I think that Python's dynamic typing is not that bad at all. Especially when it comes to programming. I just know Vencabot / Dave is a swell guy. I think he's on to. I'm glad you feel that way, man. I'm doing my damnedest out here in these streets. Let's run the module. Now we've got some gold. Let's hope we get lucky again with Baby Goki. First roll. Ah, fuck. We got Goki. So let's use our spear. Kill him in one hit. That makes life easy, right? Item, spear. You're done. Okay, look at that. See, so what happened here? We killed Goki. Chun-Li's victorious. Chun-Li earned 10 gold. Chun-Li is now carrying 10 gold. Nice. Then we have the new health, right? Goki's here now. Let's change the code and make it a little bit more clear what's happening, right? So basically, we won our fight, and then we have this weird code here. It's weird text. You know, we've got HP and, you know, other HP showing up. Let's actually fix it and make it more clear. Go to our new battle, right, for do battle. And say here, first of all, print a blank line at the start of every fight. And then print off, let's actually get rid of that blank line. And let's just print off game state, monster name, plus is approaching. Right? Then print a blank line. There you go. So now we have a new fight here. We can say so-and-so is approaching, see their health. That's great. Let's go down here to do battle and print off a blank line after every battle. There you go. That means we don't need a blank line at the end of our battle, right? Or we don't have one, that's fine. Okay, cool. So let's start this fight now. I think it's a bit easier to read, perhaps. What's your name, son? I'm going to be Chun-Li again. Because I want to have an advantage. I want to survive as long as I can. We're fighting Goki first. Let's use our spear to kill him in one hit. Use items, use a spear. He's dead. Okay, so Chun-Li's victorious. Chun-Li earned 10 gold. Chun-Li is now carrying 10 gold. Goki is approaching. There's his health. Okay, so we got another Goki. Bad luck. Let's just attack him and hope for the best. He tattooed me. That sucks. He can kill me next turn. I have a potion, though. He only gives me 10 health, though. He has more than 10 attack power. That's fine. We got to survive, right? Item. Use our potion. Okay, so he taunted me. I've got 20 health. Let's attack him again. This should kill him, right? I have 10 attack power. Okay, so he's dead. I got 20 gold now. So our gold is accruing, right? We're accruing more gold. And on our next stream, we can spend that gold to buy back items like spears and potions. We have another Goki. That sucks. So we've got 20 HP left. He's got 20. I have 10 attack power. If I get lucky... No, I can kill him. I can kill him for sure, right? If he attacks me, I'll have 5 health. But I can attack him twice, but I'll kill him. Hopefully he taunts me, though, or something. Yo, he taunted me. Let's go. We got 30 gold now. We're still at 20 health. We got another adult Goki. That sucks. Let's just attack him. Hope for the best. Okay, so I can't heal myself now, but I can kill him. I can kill him now and survive with 5 health. We got one more adult Goki. That sucks. So basically, I can only win now if he doesn't attack me at all. Okay, he flexes. So I got another Goki on, down. Another adult Goki shows up. Let's attack him. Okay, so I can't kill him in this turn. He's defending. He's going to take half damage. So if he defends next turn, or if he taunts me, I can kill him. Okay, so I can kill him. He defended again. Yeah, tell me so overpowered. Here's Baby Goki. Now, he has more than 5 attack power, right? So he can kill me in one turn as well, I think. I still can't heal myself yet. Let's go see what his attack power is like. Where is he being defined at? Create new monster. So Baby Goki has 8 attack power. Holy shit. So he's definitely going to kill me if I don't kill him first. Okay, I can kill him now. Another Baby Goki. Let's go. I got 70 gold. Yo, he's not attacking me. He has a 1 in 3 chance to attack, right? So I'm pretty golden. Okay, Baby Goki. Alright, so he finally killed me. Got that shosh. But I died with 80 gold. Not too shabby. So our game now is way more interesting than when we started, right? But we really haven't added that much code. We've moved some code around, right? Made it more easy to understand what's happening in that code. But our actual code itself has not been added to very much. And yet the game has become so much more interesting, right? We have money we can earn now. We've got continuous battle. We've got a variety of playable characters and monsters. We've got, randomization. So the enemy turn is randomized now. That's kind of fun. Kind of super fun. But I'm missing the chat here. Ryan says, JavaScript has given dynamic programming a bad name. Oh, fuck JavaScript. American says, I can't help but hear this in my head. Shot to the heart and you're to blame. JavaScript gives dynamic programming a bad name. It definitely does, though. Definitely does. Bon Jovi is right about that. Ryan says, Lisp did it right in the 70s IMHO. I know Lisp was dynamically typed. I never used it myself. So guys, next week on Friday from around 6 to 9 p.m. Eastern, we're going to be going back to this program and adding more to it. We're going to make it object-oriented. So up to this point, guys, we've been using functional programming, basically, where we have been putting all of our code into functions and supplying an argument that we're going to be using in that function, right? The game state in this case. It's not really functional, it's not fair to say, because we're using the game state, which is a mutable object. We've been using that very heavily, the mutability. But in any case, next week we're going to be defining our own classes and using those to make our code even more readable. But what's really interesting is that not only will it be more readable, it will be a lot easier for us to do things like make multiple monsters. As you can see here, guys, there is a lot of redundancy. We have, when we make 2 different monsters, Baby Goki and Adult Goki, we have to define his HP as a whole line of code. We define his attack as a whole line of code. And we define his gold value as a whole line of code. If we wanted to add a third monster, that would mean 4 more lines of code. And then another monster, 4 more lines of code, over and over again. What's really cool about classes is that it makes manufacturing similar things very easy. We can have a monster class and then manufacture them with different attributes very quickly and efficiently, and in a very easy to read fashion. We can also add in more complexity to things like our player character. We can have him have more complex inventory. Items can be equipped starting next week. We can do things like have shops that we can spend our gold on to buy items. That's going to be made a lot easier by learning about classes and object-oriented programming. So this code right now, which we've done pretty well with for it being a what is this 200 some lines, 220 lines, not too shabby. A very fun game for that short of a code. But next week, guys, you're gonna have your minds blown by how much simpler it can be by using classes. It's gonna be a lot of fun, guys. Thanks for hanging out with me. If you like me in the channel, you want to keep it online, check out patreon.com/Vencabot. Even $1 a month's a huge help. So $1 a month helps you buy groceries and gas and that sort of thing. I stream for 40 hours a week every week. It's a lot of work, but it's also a lot of fun though. It's a lot of fun. It's a labor of love, but I really can't afford to do it in the long term without your guys' support on Patreon. That's at patreon.com/Vencabot. If you're like me, you want to help out, you enjoy the channel, but you're not exactly rolling in dough, you have a budget to work with. I totally understand that, guys. Trust me, I'm broke. I'm super broke. I know the struggle. You can help for free. Get in the chat, come say hi. You guys are the reason why I can stream at all. If not for you guys in the chat, there'd be no stream. Definitely. So you guys are the best way to help the channel out is to get in the chat, come say hi. You can also follow on Twitch for free. Tell your friends we're here. Spread the word about the channel. Check out YouTube at youtube.com/VencabotArchive, or just search on there for Vencabot. You'll find me that way too. I've got lots of long plays. Got more than 1,100 videos. 1,100 YouTube videos, each one about 2 hours long, including more programming. We have the entire first season of Intro to Python, where we started off with a very basic programming concepts on day 1, and then by day 6, we had a fully working Pokemon battle as our first project. Very shortly on there, we're going to have our entire second season, which is an adventure game like Zork. Not so much an RPG, but there's like exploration and puzzle solving. That'll be on YouTube very soon. We also have lots of long plays, retro games, modern games, horror games, shooting games, AAA games, and indie games, puzzle games. We've got online stuff and single-player stuff. We've got Fortnite Battle Royale, RuneScape, MapleStory. It's a lot of cool content, lots of fighting games, Third Strike, Street Fighter 3. It's I'm very proud of the YouTube channel, but it's not really doing that well in terms of subscribers. If you guys want to subscribe over there, I very much appreciate it. Check out some videos. I put a lot of work into that. I'm going to go very short break, guys. Come right back with a pizza and a movie. Our streams are starting for tonight, guys. After pizza and a movie, it's going to be some Minecraft. We're going to watch a movie called DOA. It's a 1949 public domain noir film that I hear is pretty good. I'm going to get some food and enjoy that. I'll see you guys very shortly. So Lumen says, how are you broke as a software engineer? This is a hobby indeed. Fame says, he's definitely very talented when it comes to... Thank you, Poison Fame. I appreciate that. Yeah, my friends are professional software engineers, and they're pretty broke. I think that it's a pretty... it's a field that's a lot of competition. And I wouldn't... I'm not going to say that you can get rich being a software engineer, that's for sure. You probably can, but it definitely takes a lot of work. Welcome aboard, Lumen.
You're trying to have a good time, dude. Have a good time.
Yo, pizza, let's fucking go. I got the pizza set up to deliver at 9 o'clock. Hopefully they come through. I'm going to use the meantime to get things set up here.
Got like a beginner. So he starts around with the jab machine gun blow. That's fine. It's all good. Simply doesn't even know what the button to. Say that a random button.
Awesome, Lumen.
Full screen.
Maybe I'll look into it again. Thanks for the advice, dude.
Got the rage quit?
It's gonna be lit, Fame. I always love pizza and whatever, man. Pizza and cartoons is always fun, unless we have technical problems. That Casper night kind of sucked. Casper was so damn quiet. It's so hard to get the volume amplified to what it needed to be at. I think with all my fucking equipment here, I could do that, but it was so fucking quiet with all of my tools and all my skills.
Good shakeout.
I couldn't make that shit loud enough to hear.
Oh, that's a punish. Big damage.
But the other cartoon nights were great, and the last movie we watched was awesome. I got high hopes for this one too. When I'm reading, it's considered to be a pretty good film. So we'll have food, we'll have a movie. It's gonna be lit. Yeah, Faust. It was pretty lame. Fuck Casper. They're shitty cartoons too. They're bad cartoons, and we had technical problems.